Welcome to yet another chapter of AI for Managers course. In this chapter, we will briefly discuss well-known implementations of AI algorithms in real-world projects. We will look into 4 familiar industries which heavily use AI. We will see how Alexa has changed the way we interact with intelligent agents, how product recommendation engines are revolutionizing e-commerce, how AI is being used in self-driving cars, and how AI is helping in lowering data center power consumption costs. Alexa has suddenly become a household appliance, listed as the top 5 items sold on Amazon.com continuously for the last couple of years. This is mainly because of the ease at which it can perform the 3 key tasks: voice recognition, responding to your queries, and connecting to other IoT devices. Alexa is a powerful little hardware which is capable of receiving your voice, sending it to the cloud, and playing back the text from the cloud. It records your speech. If the speech contains invocation word Alexa, sent to the Amazon servers, voice is broken down into individual words, contexts. Voice to text conversion, understand context and intent, for example, keywords and Amazon lex, respond back with either information or execute a task. First part of Alexa is the voice to text engine. It is basically a model that has been trained on voice samples along with text labels. Its role is to convert the voice into text. Second part is understanding the text. This again is another model that has been trained to infer the context from the text and map it to relevant answer. Third part is the text to speech converter. This converter is again a model that has been trained to generate speech from words. So you can see that machine learning is used in multiple ways in Alexa. The next example is recommender systems. Some of the recommendation engines that we come across daily are Facebook Friends Suggestion, Amazon Product Recommendation, LinkedIn Connections, Netflix Movie Recommendation. Broadly, there are 2 methods of choosing which products to recommend: collaborative filtering and content-based filtering. Collaborative filtering finds users similar to the customer and recommends the products those users bought or interacted with. By interactions, we refer to either viewing, buying, or rating a product. To effectively use collaborative filtering, the system needs a large dataset with active users who rated a product before in order to make accurate predictions. In content-based filtering, recommendations are made based on the information the customer has already generated on the system. In this method, products that are similar to the ones he had interacted with in the past are recommended to him. Let us understand collaborative filtering with an example of Amazon's product recommendation engine. Imagine that you bought a GoPro camera. The system finds out other customers similar to you in terms of buying or browsing habits, that is, either bought a GoPro or were actively searching for GoPro, and recommends the next product to you. The assumption here is that you are likely to buy the recommended product since other users who are similar to you in their buying behavior also bought these products. In content-based filtering, Amazon's recommendation engine displays to you similar products based on your past behavior. Imagine you bought a book called Equations in Science. Since Amazon has all the details of the books that you had bought or searched for in past, it recommends you the books that are very closely related or similar to the book Equations in Science, and also the other related books that you had bought or searched for in the past. Let's go into the details on what AI algorithm actually do when giving you the recommendations. Let's take the case of content-based filtering. Imagine that you had bought a book. Every product in Amazon's product catalog is populated with a list of features or metadata. For example, in our case, the metadata includes the price, title, author, the category it belongs to, the topic under which it comes, the keywords that are used in the reviews, etc. A scoring algorithm lists other top books which have a similarity index very close to that of the book in question, based on how similar the features are to the book which was already bought. The recommendation engine lists the highest scoring matches. By definition, higher the score, the more similar the books are. This method relies solely on the object features and not on the preference of the users. On a side note, when Amazon open sourced their proprietary library for building deep learning neural network algorithm named DSSTNE, pronounced as Destiny, we came to know how its recommendation engine could achieve such good accuracy. Destiny works well with large feature vectors with sparse data. It works well where other solutions like Apache Spark ML, etc. fail to perform. It's well written in C++, but support for Python has been planned. Virtually every automotive company is getting into the race to put their self-driving cars on the street. But there are some non-automobile companies who are contributing to the ecosystem in not the conventional ways. One of them is NVIDIA, the company that makes the GPU cards, the graphics processor unit cards. We can divide the self-driving car into three parts: eyes, brain, and the backbone. Eyes stand for sensors, backbone includes the IoT connectivity, and the brain represents the AI models, or you can say software. A self-driving car can be considered as a giant data collection machine. It constantly scans the environment around it using the various sensors and tries to make a virtual image of its surroundings. By the way, this is how a 3D virtual image created by LiDAR looks like. Combining the 3D virtual image along with the real world, there are 4 steps involved in the process: data collection, training, simulation, and driving. Training the model on real-world scenario, that is, on the road, is not feasible and it's very costly too. Therefore, the model is trained on hours of simulated data. A human closely monitors the system's actions as it acts in the real world, providing feedback when the system has made wrong decisions. Taking the discussion forward, let's look into a case study in a non-tech industry: power optimization in a data center. Recently, Google announced that using its own AI, DeepMind, they were able to reduce the power consumption in their data centers by almost 40%. This is a significant step forward. When traditional rule-based approaches fail, AI works well in these environments because of primarily 4 reasons. The large industry equipments used in data centers interact with the environment and with each other in very complex, non-linear ways where traditional rule-based systems fail to adapt. The traditional systems could not envision every possible scenarios and changes, like the rapid changes in the weather and the other internal and external factors. It is difficult to customize the system to cater every possible scenario. Every data center is unique in the kind of equipments, requirements, and the environment. So, a general intelligence model is required to address without having to do infinite customizations. All these factors helped DeepMind's algorithms achieve what traditional industrial systems could not achieve. DeepMind's work can be roughly summarized in 3 steps. Collect all the historical data from thousands of sensors and input devices, along with other internal and external operating variables of the data center. Train an ensemble of neural network on all possible variations of the input features. Predict the 2 key external factors, that is temperature and the pressure, for the next hour. What DeepBrain did is much similar to a traditional train and predict machine learning model. But the important takeaway is that it demonstrated that it was possible to model a very complex traditional system which could be controlled by an AI model. And the AI model could achieve very high performance improvements. This graph summarizes the performance improvements that were obtained from implementing the AI system. Notice how the power usage drops significantly while the other systems take over the operations in the data center. Thank you for watching Generalized AI chapter.